Hello everyone, I welcome you all for the course Engineering Metrology. So this is the third lecture on the topic line standards and end standards and linear and angular measurements. So these are the contents of the today's topic. We recall the lecture 2 and then we will discuss the slip gauges, ringing phenomenon of slip gauges, manufacturing of slip gauges, applications of slip gauges, and we solve a numerical problem on the slip gauges, and then we'll discuss what is dial indicator and its working mechanism, and then we will conclude by summarizing these points. So in the last lecture, that is in the second lecture, so we discussed the micrometer. So micrometers are used for measuring the both external dimensions and internal dimensions of maybe length or maybe diameter, maybe thickness or width. And this micrometer works on the principle of screw and nut mechanism. So we have the external micrometers and the internal micrometers. So we have the external micrometers and the internal micrometers. So and we discussed the working of micrometer and the anatomy of outside micrometer, and we discussed the various types of micrometers used for the various purposes. And then we discussed the depth micrometer, that is used for measuring the depth of the holes, slots, and recessed areas. The depth micrometer is calibrated in the reverse direction, whereas the outside micrometers and micrometers are calibrated in the forward direction. And then we discussed the telescopic gauge. It is used for measuring the internal holes, slots, and grooves, etc. So this is this telescopic gauge gives the indirect measurement. So, but whereas outside micrometers or inside micrometers or depth micrometers will give the direct measurement. So, but the telescopic gauge will give the indirect measurement. So you have to transfer the dimension onto the either vernier calipers or micrometer for getting the dimension of the component. And then we discussed the dial bore gauge, that is used for measuring the inside diameter of the hole or cylinder or pipe, so with a high degree of accuracy and speed. Coming to the today's class, slip gauges. So as you know, the micrometers or vernier calipers or depth micrometer can be used for measuring the for the measurement of the dimensions with high accuracy and precision. But the repeated use of these micrometers may cause any minor misalignment of the spindle that causes the error in measuring the in taking the measurement of the dimensions. So repeated use of this screw or joint that results in a rapid wear and tear takes place, so which can lead to the accumulation of the errors in measurement within a short period of time. So these micrometers and vernier calipers can be used to check the tolerance of within 0.02 mm to 0.02 mm only. But we want to measure a very fine tolerances. These micrometers and vernier calipers cannot be used, and these are not effective for very close tolerances. So these micrometers and vernier calipers are used in the tool room and other precision works. So we require a instrument which can counter these limitations and to provide the high degree of accuracy and can measure the very fine tolerance elements up to 0.01 to 0.001 to 0.0005 mm. So this can be happened so with the help of slip gauges, or this can be achieved with the help of the slip gauges. So these slip gauges are practical end standards and can be used in linear measurements in many ways. So these slip gauges were invented by Swedish engineer C.A. Johansson. So these slip gauges are rectangular blocks made of hardened alloy steel, having the cross sections 30 by 10 mm. So this is the length of the slip gauge is 30 mm, and width of the slip gauge is 10 mm, and the thickness varies. So the slip gauges are made with steel materials because it is more economical and has the same coefficient of thermal expansion as the majority of steel components used in the production. So these slip gauges are hard. The surfaces. This is the top surface and this is the bottom surface. We have these top and bottom surfaces are hardened to make the slip gauge wear resistant, and then these slip gauges surfaces, flat surfaces are stabilized at at sub-zero temperature to relieve the stresses which are developed during the heat treatment process. And then after that these surfaces, top and bottom surfaces are finished using the lapping operation to get the high degree of accuracy and flatness and surface finish. So, and the height of the slip gauges is engraved on the rectangular faces, and also features a symbol to indicate the two measured planes. So these slip gauges are not only rectangular blocks like this. We have the three basic shapes. It may be rectangular blocks, maybe square blocks without central hole, and the square block with the central hole. So these blocks are rectangular blocks most commonly used because they can be used conveniently where the space is restricted, and another one is where the excess weight is to be avoided. So in these two conditions, so we can use rectangular blocks. And square slip gauges have larger surface area and less wear rate because of uniform distribution of stresses during the measurements. These slip gauges can also adhere better to each other when they are rung together. And square gauge blocks with the central holes permits the use of tie rods, which ensures that the building up of the slip gauges that do not fall apart. So the slip gauges are classified into grades depending upon their guaranteed accuracy. So these gauges are designated into 5 grades: grade 2, grade 1, grade 0, grade 00, and inspection grade. And grade 2 is the workshop grade slip gauge. This typically used for setting up of the machine tools, milling cutters, etc. on the shop floor. Whereas grade 1 slip gauge is used in tool room applications for setting up of the sign bars, dial indicators, and calibration of vernier calipers, micrometer instruments, and so on. And grade 0 is inspection grade of slip gauge, which is limited. So this grade is used by the limited people because the extreme care is to be taken to safeguard it against the rough usage of the grade 0 slip gauges. And grade 00 is the another slip gauge set. This is used in standard rooms where you need to calibrate the grade 1 and grade 2 slip gauges. And calibration grade is the special grade with the actual sizes of slip gauges stated on a special chart supplied with the set of slip gauges. So the slip gauges are available in standard sets in both metric and inch units. So let us, for example, if we consider the M103 slip gauge set. So this set consists of one slip gauge of thickness 1.005 mm, quantity 1 unit. And in the step 0.01, we have the 49 number of slip gauges from 1.01 to 1.49. And in the step 0.5, we have the 49 slip gauges, 0.5 to 24.5. And in the step 25, we have the 4 slip gauges from 25 to 100 mm. That is, in total, we have the 103 slip gauges. Similarly, we have 122 slip gauges, 112 slip gauges. So as the number of slip gauges increasing, the accuracy is also increasing. So this is also we have one M88 set and there is a M47 set with different ranges and steps. This is also M47 set and M32 set and M18 set. Next, so ringing of slip gauges. So what is ringing? So ringing is the phenomenon of adhesion of two flat or smooth surfaces when they are brought into close contact with each other. So in this ringing process is adapted to pile up the required height using the number of slip gauges. Let us we have the number of slip gauges like this. So we need to add one over the another. So by adhering one slip gauge to the other slip gauges, so to get the required height. So for that purpose, we use the ringing process. So in this ringing process, what happens? The two cleanly surfaces between the two cleanly highly ultra lapped surfaces creates a cohesive force in between the molecules, so that causes the adhesion of the two blocks, so which almost serve as a single block and can be handled and moved around without disturbing the position of the individual blocks. So if the surfaces are very clean and flattened, the thin layer of film is separating the blocks will also have negligible thickness. If they are properly wrung and stick together, the air gap between these two can be very less, a negligible thickness. If faulty ringing of these slip gauges or if you use the more number of slip gauges to pile up the required height, so the air gap between the two slip gauges also accumulates and increases the error in measurement. So the stacking of multiple blocks of known dimensions will give the overall dimension with the minimum error. This is the procedure involved in ringing of the slip gauges. First, we have to clean the slip gauge surfaces with a fine brush, like camel hair brushes are often recommended, and dry pad, and then overlap gauging surfaces by about 1/4 of their length, as shown in the figure A, and then we slide the one block perpendicularly across the other block by applying the moderate pressure. So we should not apply undue pressure. So the two blocks should now form the shape shown in the figure B. And then now gently rotate the one block, gently rotate one of the blocks until it is in line with the another block that is as shown in the figure D. So this is the ringing procedure of the slip gauges. And then how do you manufacturing of the slip gauges? So the manufacturing of the slip gauges to the desired accuracy and high precision is one of the major challenge for the mechanical engineers. So the slip gauges should meet the high standards of accuracy, flatness and parallelism and surface quality. So there are several recommended methods of manufacturing of the slip gauges. So here we have the two methods. Internationally acclaimed methods are the ones recommended by the United States of Bureau of Standards and the GS method. There is a German method. In India also the slip gauges are manufactured as per the guidelines recommended by the National Physical Laboratory. So these are the steps to be followed in manufacturing of the slip gauges. So the first step is you have to select the high grade steel gauge blanks and then with the appropriate size. And then the second step is these are subjected to harden and then do the rough grinding operation. After that, they are stabilized at sub-zero temperatures to provide the stability of dimensions and to relieve the internal stresses. So after relieving the internal stresses, so you have to take the 8 blanks of similar nominal size that is mounted on a 8 coplanar faces of a magnetic jet. So here the magnetic jets are used to machine the very thin workpieces. And then the first set of faces is lapped truly flat by using the lapping operation, and then you change the position of the faces of the slip gauges, and then again do the lapping operation on the other opposite faces of the slip gauges by keeping the slip gauges on the magnetic check. Now you got the flatness by doing the lapping operation. So in order to get the accurate parallelism and equality of size, you can achieve by interchanging the 4 of the 8 gauges. So we have the 8 gauges here. This is 1, 2 is one gauge, 3, 4 is the another gauge, another slip gauge. Here 2, here 2, here 2, here 2. Total 8 gauges. Now we are interchanging the 4 slip gauges out of 8. So that is, this slip gauge is changed, interchanged and turned, and this slip gauge is interchanged and turned, right? So we'll get this arrangement. So here this is 3, 4, 1, 2 is here, and 3, 4 is here. 3, 4 comes to here and turned, right? Turned the ends. Similarly, if here 15, 16 is there, this will be turned here and interchanged here and turned. So 15 comes here and 16 comes up. Similarly, this is 7 and 8 is interchanged and turned. Okay, 11 and 12 is also interchanged and turned. So what you will get? So here 9 and 10 is same as it is. Here 7 and 8 is interchanged and turned. It becomes 8 and 7. Similarly, there is 11 and 12 is there, that is interchanged and turned. So we will get this. Again, we have to do the lapping operation. So any errors in the parallelism are equalized. So once by doing this operation, once this operation is completed, then you have to take all these 8 slip gauges and you check whether they are produced to the required size or not. So in order to check this, you have to pile up all these slip gauges and you can get the aggregate size, and then you compare it with the master size using a suitable comparator. So the magnification 8 is obtained in this calibration. So let us total 8 slip gauges we have. Magnification is 8. Suppose the total 8 length is 50 mm, or let us 50.01 or 08 you got. 50.08 mm you got during the manufacturing process by aggregating all the 8 slip gauges. Okay, and the actual standard length required is let us 50 mm. Let us 50 mm. So what is the error involved in all the aggregation of 8 slip gauges? 0.08 mm. Now this 0.08 mm is distributed to all the 8 slip gauges. Distributed to all the 8 slip gauges, and each slip gauge is produced with let us error 0.01 mm. So if necessary, you can individual blocks can be mounted on the check, and you can adopt the same procedure to get the individual lengths within the required accuracy. So this is the manufacturing process involved in the manufacture of the slip gauges, and where we can use these slip gauges, applications of slip gauges. So these are used to check the accuracy of verniers, micrometers, and other measuring devices. And also you can use these slip gauges to set the comparator to a specific dimension. So we need to compare the dimensions of the component with the standard dimension using the comparator. And this can also be used in a direct precise measurement where the high accuracy of the workpiece is important. And also we can use frequently in combination with the sine bar. We use the slip gauges for measuring the angle of the workpiece. And also we can use the slip gauges to check the gap between the parallel locations. So in all these cases, we can use the slip gauges for taking the measurement or setting the workpieces to the required angle. So let us, if we consider on a problem on slip gauge, here the slip gauge with the 87 pieces as under is available. So this is the range is given for the slip gauges, and we have the steps of the slip gauges, and the number of blocks available is also given. The objective is to build the following dimensions with the minimum number of slip gauges: 29.758 dimension and 46.635 dimension. So let us, if we consider the first case, 29.758 mm, so we need to build using the minimum number of slip gauges. So the condition is we have to use the minimum number of slip gauges. Otherwise, what happens is the air gap will increase as the number of slip gauges increase. So the error also accumulates. So in order to minimize that, we have to use the minimum number of slip gauges. So for that purpose, let us first we have to start with the last digit of the dimension, that is 8. So here 8 means after point we have 0.008 or 0.118 or 0.228 like that. So here 0.008 is not available, but 1.008 is available in the range 1.001 to 1.009. Okay, we will select 1.008 slip gauge. The total dimension left here is 28.75. Okay, and then we will select the last digit again. This 5 is 0.05 is not available, but right 1.25 is available in the range 1.01 to 1.49. Even 1.35 is also available, 1.45 is also available, right? But 1.75 is not available. So you have to select the slip gauge such that the after point the dimension should be possible to left with 5. So for that we have to select 1.25 slip gauge. So the dimension left is 27.5. So now there is a 20 mm slip gauge is available, and 7.5 mm slip gauge is available in this set. Okay. So, but there is no 27.5 mm slip gauge in either of the ranges. So for that we have to use 7.5 mm slip gauge and 20 mm slip gauge. It is possible through this slip gauge set. So what are the how many number of slip gauges we used here? 1.008 one slip gauge, and 1.25 mm one slip gauge, and 7.5 mm one slip gauge, and 20 mm slip gauge. Total in total we used 4 slip gauges to build up the 29.75 mm dimension. Let us, if we consider the another example, the build up the dimension 46.635. So here also we start with the last digit of 5. So that is 1.005. We can select one slip gauge which is available, and then the total dimension left is 45.63 mm. And then we start with the last digit, that is 1.13, because 5 has to be left, and 1.13 is available in the range 1.01 to 1.49, and the remaining dimension left is 44.5. So 40 size is available in 10 to 90, and 4.5 is also available in 0.5 to 9.5. So for you have to select 4.5 mm slip gauge and 40 mm slip gauge. So total number of slip gauges are 40, 4.5, 1.13, and 1.005. So total 4 number of slip gauges. If you use more than this, the error will accumulate and you will get the inaccurate dimensions. Next, what is a dial indicator? So dial indicator is also called the dial gauge. So which is acts as a comparator So it is simplest and most widely used device for comparing the workpieces against the masterpieces. So this consists of a body with a circular dial, and there is a measuring point or contact point which is connected to the gear train, and there is a indicating hand. There is a indicating hand that directly indicates the linear displacement of the contact point. So the contact point in a dial indicator is of an interchangeable type and provides versatility to the instrument. So these measuring contact points are contact point is made with different material, wear resisting materials. This may be boron carbide, heat treated steels, sapphire materials, and diamond materials are the some of the preferred materials for the contact points. So this is the working mechanism of the dial indicator. So here this is the plunger, and this plunger is attached to the bottom of the rack. This is the rack. This is the rack. At the bottom of the rack, this plunger is attached, and there is a coil spring, so that resists the measurement moment and thereby applies the necessary gauging pressure. And also this helps to return the mechanism to the at a rest position after each measurement. Suppose if the coil spring is not there, the operator has to put some pressure or apply some pressure on the plunger to take the accurate readings. And here the plunger carries a rack which is meshing with the gear A, and this gear A, on this gear A shaft, the gear B is also mounted. Okay. So a rack guide, here there is a rack guide which prevents the rotation of the plunger about its own axis. It has to, the plunger, this is the contact point. If the contact point contacts with the workpiece, the plunger has to move only in the upward and downward direction. It should not rotate about its own axis. So this rack guide helps in preventing this rotation of the plunger about its one axis. The small movement of the plunger causes the rack to turn the gear A. And another large gear is mounted on the same shaft of gear A. So this gear B is also connected to the gear C. So on the same shaft of gear C, there is another gear D is mounted. And this gear D is connected to gear E, and gear E is connected to gear F. And at the center of the, and on the same line, same shaft, the indicator pointer is connected. Whatever the moment the gear F gets, that is right given to the indicator. That indicator shows on the dial, shows the reading on the dial. So the overall magnification obtained through this gear train A, B, C, D, E is, one is this number of teeth on the gears divided by number of gear teeth on the E. You will get here one set of magnification, and there is another set of magnification we obtain. This gear B is also connected to gear C. The total number of teeth on the gear B divided by the total number of teeth on the gear C. Here also we got the another magnification. So here the total magnification is obtained in two stages. This is the first stage and this is the second stage. So the total magnification is the product of the first stage and the second stage. And here there is a hairspring is provided to the gear, to the dial gauge, because it is used to avoid the backlash error and also to control the movement of the plunger to retain its original position. So for this purpose, the hairspring is used. So this is the today's class. So the slip gauges are available in three basic shapes: rectangular, square with the central hole, and square without central hole. So these slip gauges are used to pile up the required height, to measure the dimension with a very high accuracy and precision, and to provide a very close tolerance limits on the components. Slip gauges are designed in 5 grades: grade 2, grade 1, grade 0, grade 00, and calibration grades. So grade 2 is the workshop grade, grade 1 is the tool room grade, grade 0 is the inspection grade, grade 00 is the calibration special grade, which is used for calibrating the grade 2 and grade 1 slip gauges. And then we adapt to the ringing phenomenon. We understood what is the ringing phenomenon. So for piling up of the number of slip gauges to get the required height. So this ringing phenomenon of two flat and smooth surfaces, when they are brought into close contact with each other, the adhesive, due to the adhesion of the or the between the two cleanly surfaces, what happens? The molecular attractive force will develop that causes the two slip gauges to stick one to another. And then we discussed what is the manufacturing of the slip gauges. So in this, first what we have to do, we have to select the slip gear. We have to select the steel blocks of similar dimensions, or having the same nominal dimension of steel gauge blocks, and then these are hardened and do the grinding operation, and then stabilization has to be done to relieve the internal stresses, and we have to place this 8 slip gauges on the coplanar faces of the lapping magnetic check, and then we will do the lapping operation on the top one on the one faces of the all the 8 slip gauges, and again we will do the lapping operation by turning these slip gauges to the by turning these slip gauges. On the other faces also we'll do the same lapping operation. So we will get the flatness is achieved in order to have equal parallelism. So we have to turn the 4 slip gauges out of 8. We have to interchange the 8 slip gauges. We have to interchange the 4 slip gauges out of 8 slip gauges and turn it, and again do the same lapping operation. Okay, so in order to check this whether the slip gauges are manufactured to the exact size or not, so we have to pile up all these 8 slip gauges, and then we compare with the master slip gauge. So if any deviation is there, that deviation is to be distributed to all the individual slip gauges. So if you want to produce the individually each slip gauge to the required height, we can also do the same procedure for manufacturing of the slip gauges. And these slip gauges can be used for checking the vernier calipers, micrometers, and other measuring devices. And we can also use for setting up of the comparator to a specific dimension. And these are frequently used with the sign bar and to measure the angle of the workpiece. And to check the gap between the parallel locations. So in combination with the sign bar, we can use for measurement of the angle of the workpiece. Dial gauge is primarily used to compare the workpieces against the master gauge, and we discussed what is the working mechanism of the dial gauge. So these are the references we considered for preparing this material. Thank you.